This drone can transform its shape mid-flight, autonomously decide on new formations, and navigate through tight spaces on its own. And as surprising as it sounds, the inspiration for it came from ancient mythology. In his workshop located in Tokyo, Moju Zhao works on what might be the future of the drone industry. This marvel of engineering can change its shape on the go, allowing it to navigate through different spaces with ease. The Dragon, which stands for Dual Rotor Embedded Multi-Link Robot with the ability of multi-degree of freedom aerial transformation, is composed of multiple modules linked by battery-powered hinged joints. These modules, equipped with maneuverable thrusters, allow the drone to make autonomous decisions on how to change shape to navigate past obstacles. Led by Moju Zhao, the team was able to make the Dragon stay airborne for around 3 minutes. Now they are looking to increase its modules and even add grippers to enable it to pick up or manipulate objects. But the innovations don't stop there. The researchers envision a future where the Dragon not only flies, but also walks on the ground. Imagine a drone that can seamlessly transition from flying to walking, optimizing its energy consumption based on the environment. This vision aligns with Japan's broader roadmap for drone technology, which sees potential applications in areas like delivery, farming, and even unique solutions like drone-powered parasols. The serpentine shape and the name of the drone were inspired by dragons depicted in ancient Asian mythology. MIT, on the other hand, found its inspiration in a much more modest animal. They've developed insect-sized drones with soft actuators, mimicking the agility and resilience of bugs. These tiny drones can withstand collisions, making them perfect for navigating confined spaces. The soft actuators, essentially artificial muscles, allow these micro-drones to flap their wings rapidly, achieving impressive flight capabilities. These drones are so agile that they can even perform somersaults in the air. But why the focus on such small drones? Well, the potential applications are vast. From pollinating crops and inspecting complex machinery to search and rescue missions, these tiny robots could revolutionize various industries. For instance, inspecting a turbine engine's interior would be much easier with a small, agile drone equipped with a camera. In agriculture, as bee populations face challenges, these drones could step in to help with pollination. Now let's delve deeper into the technology behind these innovations. The soft actuators in MIT's drones are made from thin rubber cylinders coated in carbon nanotubes. When voltage is applied, these nanotubes produce an electrostatic force, causing the rubber cylinder to elongate and contract. This rapid movement results in the flapping of the drone's wings. The design is not only power efficient, but also incredibly resilient. These drones can recover from collisions, making them ideal for real-world applications. Furthermore, the fabrication techniques behind these drones are groundbreaking. MIT's approach to building soft actuators involves layering elastomer and electrode, with each layer being about the diameter of a red blood cell. This meticulous process results in actuators that require significantly lower voltage and can carry more payload. The future looks promising, with hopes to reduce the thickness of these layers even further, unlocking more potential applications. The future of drone technology is not just about scaling up, but also scaling down. As we look ahead, it's clear that the combination of innovative design, inspired by nature, and advanced fabrication techniques will pave the way for drones that can operate in environments previously deemed impossible. Whether it's a shape-shifting drone navigating tight spaces or a micro-drone pollinating a field, the next generation of drones is set to revolutionize the way we think about robotics.